Morning, ladies and gentlemen, and you're all very welcome to the Irish Bioenergy Association webinar number 21. My name is Sean Finan. I'm the CEO of the Irish Bioenergy Association. This morning's topic is on the whole area of district heating networks and incorporating bioenergy into those. Before we begin, just a brief introduction to what we do as an association. The Irish Bioenergy Association was established in 1999. We are the representative body for the bioenergy industry on the island of Ireland, and our remit covers the sectors of biomass, biogas, biofuels, biochar, wood fuels, and energy crops. Our main work is in the area of policy lobbying and advocacy, and we have a very broad and diverse membership. We're open to new members, and we're also involved in a number of research and demonstration projects. And if you want to find out more about our association, feel free to log on to our website, www.erbia.org. This is number 21 in our webinar series. We've covered a wide range of topics to date, and all our webinars are available on our website and also on our YouTube channel if you would like to go back and review or view any of our previous webinars. They take place fortnightly, so our next webinar will take place in 2 weeks' time. And if you would like to get involved in presenting at a webinar or would like to get in touch with the organisation, my own and Teresa O'Brien's contact information is available on the screen. This morning's agenda is we will have a presentation from Rory Grogan and Alexandra Ledham, and they will both present on the topic. They both represent an organisation called REHOW. There then will be a panel discussion by Noel Gavigan, who will join us for that, as well as Rory and Alexandra for a questions and answer session. And you can submit your questions through the Q&A tab at the bottom of the screen, and we will endeavour to get through as many questions as possible. The date for our next webinar will take place on the 2nd of June. The topic will be focused on community involvement in energy projects, and full details of our speaker and the finalised title will be presented on social media in the coming days. We thank you for joining this morning, and we hope you can join the next webinar. Morning's topic focuses on district heating systems. District heating systems provide both baseload and full heating requirements. The use of biomass as a fuel is very beneficial within district heating systems due to its dispatchability, meaning that it can be continuously run. It is of a lower cost than other potential options, and it is suitable for large-scale use with a steady demand. District heating systems can also utilise waste heat from industrial and commercial operations, and REHOW specialises in piping and pipe networks for district heating and provides an insight. They will provide an insight. The presentation this morning provide an insight into the opportunities which exist for district heating, and also details of some interesting projects which the organisation has been involved in will be also outlined. Our speakers this morning, and we're delighted to be joined by Rory and Alexandra. Rory is the REHOW area sales manager based in Ireland, and Alexandra is the REHOW technical team lead for district heating based in the UK. So I will now stop sharing my screen, and I would invite, I think it's Rory first, to share your presentation and to we'll look forward to hearing your presentation, Rory. Thank you.
Okay. Good morning. Sound okay, Sean?
Perfect, yeah.
Okay, lovely. Thank you very much. Thanks, Sean, and thanks for Erbia for letting us present this morning. My name is Rory Grogan. I'm an area sales manager for REHOW. REHOW itself is it's a German company founded back in 1948 in a town of the same name. Currently, we operate as an international company in about 50 countries, 170 locations from manufacturing, distribution and sales. We operate in various markets, be it automotive industry, the window industry, industrial division, And we have a dedicated then business solutions division, of which I'm part of that division. So responsibilities I'd have would be for the sales of, among other things, district heating pipework, underfloor heating, plumbing and heating, acoustic, soil and waste, to name but a few. So regarding our district heating product, we consider ourselves probably one of the market leaders in the UK market. We're also the largest stockist of pipe, district heating pipework in the UK. So we're very close to our customer base. We can react in quicker response times. We also manufacture some of the pipework in our own facility in North Wales, again, to be near to the market and again, reduce our CO2 impact on the market. So what we're going to do now is look at the agenda for today, basic principles of underfloor heating, look at some standards, the different types of material that are available, some topics about installation and design, and then finally some case studies with the question and answers. So I'm going to hand you over now to my colleague Alexander Leadham, who is our head of technical for this area, and we'll talk in a while. Thank you.
Thank you, Rory. So if you're in this seminar, you probably have either heard of district heating or are experienced in it maybe, or wanting to learn a bit more. So just an overview of what district heating is if you are new to it. So the basic principle is that there is a heat source, which is a central source for an area. You don't have boilers in the individual buildings. And this heat is distributed around via a network of pipework, delivering the heat to either domestic buildings or non-domestic, such as schools, hospitals, etc., or multi-occupancy buildings, where after that the heat is distributed to different floors and different flats accordingly. Inside of the building, where the pipework is connected to a heat interface unit, then the heating is distributed with internal pipework through underfloor heating or radiator systems, so any conventional heating systems. Energy efficiency is the biggest driver of district heating, and it's more efficient to produce energy on a local level. And the driver for district heating in UK and in Ireland is the combination of renewable energy sources such as biomass and heat pumps. There is always a benefit of not just going renewables, but also that there is economies of scale. So all these technologies are feasible on a scale where a few buildings are connected. In general, district heating or heat network would be systems that connect more than 2 or 3 buildings altogether. This technology is future-proof, so the heat source can be changed at a later stage. So if you would like to combine heat sources as well, this is possible. Having a backup boiler of some sort or change the technology completely over the next years, that is also possible. There is no maintenance for every single building as you would have with boilers. And this is one of the biggest benefits too. So there is a central plant maintained and looked after by the operator. The heat sources range from gas CHPs, which are going to probably reduce in the next years, heat pumps that have been talked about quite a lot recently, biomass and anaerobic digestion, something that we'll be talking about today, and which is really good for rural areas where there is no supply of other heat. means. Solar thermal is also technology which can be combined with others, for example, with even anaerobic digestion plants, biomass, CHPs, etc. There can be deep geothermal heat sources for heat pumps or waste heat, and waste heat can cover a range of different waste heat scenarios. It can be production factory waste heat, can be data centers, or even sometimes sewage heat or infrastructure waste heat, a lot of different options. The question is, why don't we install more district heating, and why it hasn't been as popular in the last 20 years, 30 years? And there is a mixed history. In 1960s, 1970s, the district heating was encouraged and was installed quite a lot, but it inherited this bad reputation because it wasn't a very efficient systems with lots of steam networks, which did fail and were really designed to sell more coal and not for their efficiency and not for their good design and energy savings. Later on, these kind of systems were replaced by boilers, and now we're coming back to district heating because in the economies of scale, it is a very efficient way of heating our cities and our towns and villages. Unfortunately, district heating has a higher capital investment cost, but that comes with savings in the long run. Education is one of the biggest things that are on our mind at the moment, because the low awareness of the consumers creates a block between installing a connection to a district heating systems versus a boiler, where you can have the control over what you're doing and where you want the heating placed. The webinar, next webinar of the association, I've noticed is community involvement, and this is probably a very good link to this awareness about what are the benefits of district heating system and how customer can benefit from it in the long run. It's one of the most important points here. People are used to switch providers as well. Switching your car insurance, your energy supplier, and everything on a yearly basis is not anything strange for us. And this, again, is one of the downsides of district heating, because you are connecting to a supplier and you keep the supplier for a period of time, a long time. So people find this an uncomfortable topic. So if we manage these blocks in our road to install more district heating and incorporate more district heating and heat networks in our world, in our habitats, it will be a much easier road to success here. Around policy and standards, from UK perspective, there is an experience of having biomass boom, shall I say. It has been installed in various projects with smaller and larger systems supported by RHI. Now we are observing that gas boilers are being banned for the new homes from 2025. So a lot of developers are already looking for district heating systems to be installed as a new technology in a couple of years. General district heat is only covering 2% of all of the heat demand, and this is planned to be risen to 17%, and the government is supporting. So incentives are the second point after education, which is extremely important to promote these systems. And this is something that the Heat Networks Investment Project has been working on, and the new system that is being launched, the Green Heat Network Fund, from 2022 onwards. So incentives are really helping this industry to evolve and to progress, and hopefully there will be new launched in Ireland and Northern Ireland too. The association probably knows a lot more about renewable heat policy in Ireland, so I would encourage to get in touch with my colleagues here. But from what you've probably heard and seen before is that Irish policy is to supply 40% of renewable heat by 2030, which is a good ambition. And it means that the district heating targets that would be of 10% by 2030 should increase by 1% yearly. Again, this is a good ambition, and I think it's achievable. If you're looking at the rural percentage of heat demand, this is where your biomass and anaerobic digestion and waste heat as well probably can be incorporated, and that's a huge opportunity for Ireland. If you are new to district heating, or if you would like to deepen your knowledge in a specific area, I would strongly recommend looking through the CIPC Code of Practice for Heat Networks. This is a guide that covers literally everything from the very start, feasibility study, assessing your project, putting your team together, and all the way to commissioning, looking at customer support, post-commissioning and operation of a network. It would cover different points from designing system as well, what options of materials you have, where there is a minimum requirement, as well as where best practice is recommended. So you have a choice of, in a way, levels of how you would comply with this guide. In UK, this guide is obligatory for all the incentivized systems. So if you receive funding from the government, the system has to be covered by the minimum requirements of the code. So it is a really good guide, and I would recommend looking through it. As you know, Rehau are a manufacturer of polymer systems, but I'll give you an overview of what pipe material options can be there. We are mainly looking at steel and polymer. So when you're looking at all the range of pipework, they are divided into those that are insulated with polyurethane foam. It's the rigid foam. These are the three pipes you see on your left. And the other foam is usually layered foam around the pipework, and that's the non-bonded systems where insulation is not bonding to the actual carrier pipe. Each of these pipes have their strengths and weaknesses, but we'll go through them just now. When we're looking at steel pipes, they're very strong in their temperature and pressure limits. And this is why they have been so popular for steam networks, really high temperature, like 90, 100 and plus degrees. Also for citywide networks where large diameters are really important. And these networks are stretched for kilometers of stretches across cities, or sometimes ring networks. That's where steel is at its strongest, because the pressure limits will be quite high at that point, and large diameters are a very good combination for these kind of systems. It is a very strong material, and it's resistant to any impact damage as well. On the weaknesses side, this material is quite heavy and not flexible. It always comes in straight lengths with welding requirement after each 6 or 12 meter lengths. There are some coiled solutions, but only for the smallest pipeworks at the moment. But they're not the classic steel configuration. They're more like a corrugated type. When joints are required every sort of 6-12 meters and for every directional change, it adds up the installation cost due to the fact that you're welding every single connection. At the same time, the picture on the right shows an expansion loop. So every system that is designed in steel will have to have expansion loops at every directional change or when the stretches of pipes are quite long. So this is to accommodate the expansion forces on the system. Steel is a corrosive material. And while the actual pipe is not usually subject to these corrosion problems, it's where it's welded together where the corrosion problems normally start, and that's why this kind of system requires leak detection in the long run. PPR pipes are also large pipes, but in polymer. So this PPR stands for reinforced polypropylene. This is also the same insulation as steel, polyurethane, and in general, it's available up to 315 mil in diameter. So in steel equivalent, it's DN 250. But these kind of pipes can be manufactured in slightly larger diameters too, as a custom. So if you would like to have a combination of for example, PPR, pipework, and another type of polymer like PEX, you can have a hybrid system between these two to create a fully polymer system on a larger level. So at a temperature difference of 30 degrees, so for example 70-40, you would achieve 16 megawatt covering in a 315 mil pipe, so quite a large amount. There are no expansion bands required due to the way the material expands and contracts. So as opposed to steel, this pipe can go just in a straight line without any need for the loops. These materials, all polymer materials, are highly corrosion resistant. Simply, there is no steel, no other corrosive metals in the pipe, and because of that, there is no requirement for leak detection. So you will see that most of the polymer pipes don't actually have any. The disadvantages of PPR and it's also about straight lengths. This is quite a large sized pipe with 12-meter lengths. But having said that, there is a lot more flexibility to it compared to a steel pipe, more rigid. Of course, this applies to all polymer pipework as compared to steel. They don't have as strong temperature and pressure limits as steel. So we do two different types of PEX pipes. One is, well, the PEX pipes themselves are the same, but one is with bonded PU insulation and the other is with layered PEX insulation. The advantages of both is very long coil lengths, so you don't have to have any connections in between 12-meter lengths or 6-meter lengths. So for long soft dig, especially projects where you're not required to open just a short part of a road, for example, in a city center or so, coiled pipework is really energy time saving. Has really good flexibility and no expansion bands are required. Again, for polymers, these expansion forces are self-compensating as long as you're burying the pipework in the correct manner. The compression sleeve joints that are shown in the picture are used for connecting these pipes, and it's there are no hot works involved in it, and there is no leak detection required, same as in PPR. When comparing these kind of pipes with with the ones insulated with layered insulation, of course, they're not as flexible because it's a rigid PU insulation. And as I mentioned before, steel has higher temperature and pressure limits, which applies to the non-bonded PU insulated pipe as well. Here, disadvantages are as well that this kind of insulation is of lower performance. So if you are going to, if your project requires as low heat losses as possible and it's a critical situation, then PU insulation would be the preference. The advantages of these systems is not only long coil lengths as well, but it's very flexible and it's ideal for house installations. So if you would like to naturally bend the pipe into the house, and the foam is really easy to take off. The same as on the PU insulated product, this is using a compression sleeve joint, which can be put under pressure and under temperature immediately after it has been installed. We have some samples to show you later, so hopefully Rory and I can demonstrate how they look like in real life. The problem with steel, as I mentioned, is not the pipe itself, it's the actual connection joints and the welding of them. And as you can see, according to the German CHP and District Heating and Cooling Association, more than 75% of failures are actually due to the on-site welding. And that's where if the water is coming out of the system, it will affect the pipe next to the joint as well. A picture sometimes is better than 1,000 words. You can see that on the left, the steel system has been installed with an expansion loop and a directional change. And again, these small directional changes for steel are always requiring extra welding and extra pieces of pipe under an angle. Here we are we're closing the road off and keeping the pipework occupying the whole area. If a polymer system was used in this case, you would create a T as shown on the right, without sometimes closing even the road, because you only need a trench, a small trench to bury the pipe in. When we talk about heat network design, if you're ever involved in that, we're always talking about very different generations of pipework distribution systems. So here we're talking about different temperatures, and if we're looking back at coal plant and steam distribution, that's well over 100 degrees temperatures. Slowly we have changed to the third generation, which covers biomass and gas CHP, higher temperature waste heat systems, and these would be normally around 80 degrees, 80, 60, I would say, 80 flow, 60 return. Now we're also moving further to to heat pumps and other types of waste heat industries, and these are moving towards 60 degrees flow, and these are all generations, like different kinds of generations of temperatures, while the fifth generation is probably arguably not even a generation, but a very different kind of beast. And fifth generation is ambient loops, where water is distributed in cooler temperatures and then enhanced by heat pumps at the property connections. But whichever system you choose, there is always a balancing act of combining trying to make the pipe size as small as possible, so the whole network as lean as possible, but at the same time saving on the pumping costs and making sure that we are balancing the heat loss of the pipework itself. And different methods to, there are different methods to save costs and reduce the installation costs from the very start, so capex, and that's using the soft deck areas, so you don't have to go on the roads and reinstate tarmacs. It's also using twin pipes because they occupy less space in the trench, so your civils will be less, but also twin pipes are more efficient in the heat loss. Hot tapping is something where you can avoid using dead legs for future connections, and you can actually tap in a live network at a later stage when a house would need to be connected. And using secondary spines for saving cost on creating large T's of the main spine. I've mentioned on efficiency of geopipes or twin pipes, and here you can see just an example of two pipes in single size 25 or 40 or 63 compared to the heat loss in the equivalent in geopipe work. And in each of the cases, the saving on heat loss is around 30%. Which is huge for an operator, not only for the operator, but just for the whole system, for its efficiency. So geopipes will not only save the civils cost at the very start, so part of the capex, it's also something that they will be saving costs in the long run as an operational cost. Hot tapping that I've mentioned is literally creating a T, creating a connection to a house that has not been part of the system from the very start at later stage. And it's a very fast way to create a fitting, and not much of the soil has to be opened up to create this fitting. Secondary spines, again, is a more efficient way of dealing with connections of a large spine and can save cost in the long run. One of the most important things to look into is the actual requirement for the heat. How much heat is really required, or what is the peak comparing to the real use of the system. And here you can see an example of a system that has been diversified when it was designed. So when the peak load has been assessed, we looked at how much less the heat would be used at the same time by all the properties in the area, which was around 80 connections at that stage. And while it was designed with a diversity of 85%, so 85% of every property will switch on their heating at the same time, the actual peak load on the coldest day in February was actually only at 63% peak. So this is very important to assess how much heat is actually required by all properties at the same time. Just to show you a small example of how different temperature differences affect the design of the system. If you are designing with a 20-degree delta T, so for example 80-60 compared to 80-50 with a 30-degree delta T, you are saving on the pipe diameter. So the wider the delta T between flow and return, the smaller the pipe work you will get. So again, by increasing the temperature difference, you're not only saving your heat losses, but also reducing the pipe size in the long run and the operational cost. If your system has already been designed at a 20-degree delta T, you can always change the temperature slightly to incorporate, to make sure that the same network, the same heat network can cover more buildings in the area, and increase it by another 50% in the whole district. So saving on increasing the delta T will also increase the cost saving, because your pipe work will be smaller and the capex will be lower, but also on the heat loss in the long run. So as you can see, At 70-40 or 65-35, you are saving on heat loss by 33 or 41% compared to an 80-60 as the original setup. Sometimes dropping the temperature doesn't really change much in the cost saving of the actual installation, because the pipe size for 80-60 will be exactly the same as for 60-40. What you will change here is slightly lower heat losses in the long run. So as you can see on the right, the heat loss saving for a 60-40 network would be 33%, but there is no cost saving to the actual pipe work, the actual installation cost. Among case studies that we have done in the last few years have been a few that you might have heard of, like Port Merion in North Wales. This has been a biomass system with a hotel and 30 cottages. It's actually now being extended even more. It was over 3 kilometers of network. And if you've ever seen the film Prisoner, this is where it was filmed. So quite an interesting Italian-looking village. And biomass was the key heat source here. Another project in Scotland. Here in the top right corner, you will see a small. Let me show you here. It's a small biomass setup there with a plant and supply of the material, of the burning material, with 50 apartments supplied within 1 kilometer of network of pipework through 1 kilometer network of pipe. Here again, this is just the start of the system, and there are more buildings being built at the moment for the extension of this system. Another project on your left is East Home, 16 buildings, so not a very big system, but again, still possible to connect quite a few of them. It doesn't really matter how big or small the system is, because you can always combine a few heat sources and connect them within the heat network to combine into quite a large system. One of our first district heating systems was covered by a 12-kilometer network, and that was just a few different plant rooms connected. Here, for example, Soho farmhouse is 45 luxury houses, and again, this is a 7-kilometer network now, but it's in process of extension, and there is more pipe going into the ground to supply the second phase of this development. So extensions are always possible at a later stage. The project on the left, Park 25, has 250 buildings, and they are quite dense, close to each other, because this is only a 3-kilometer network, but supplying quite a few buildings. Another project in Dundee, these are holiday lodges, and here you can see it's just over 2 kilometers of network. So projects differ. They can be anaerobic digestion source, can be biomass, but it doesn't really matter how you combine those two or just choose one of them, and it's possible to install various systems to supply heat to the buildings around the plant. That's all from me. If there are any questions, would be happy to answer them.
That's great, Alexandra, and thanks very much for a very informative presentation. And I would encourage any attendees who have questions to submit them through the Q&A tab at the bottom of the screen. So I'd now ask Rory and Noel to just turn on your cameras, and we'll just have a short panelist question before getting to some of the questions. So Noel, you work for the Irish Bioenergy Association as the technical and project executive, and Alexandra referred to in her presentation about the 40 by 30 report. Can you just give us a quick summary of that report? Obviously, it was launched last week. who launched it and what it contains, and maybe specific reference to bioenergy, but also district heating.
Yeah, the 40 by 30 report, it was produced or commissioned by Renewable Energy Ireland, which is basically a conglomerate of various renewable energy technology organisations, such as ourselves, the Irish Bioenergy Association, the District Heating Association, a number of the IWEA on wind, solar, district heat pumps associations. So we've all formed into one single group called Renewable Energy Ireland and produced this report. So there's quite a lot in it in terms of it's focused on reaching that target of 40% heat by 2030. And it's been commissioned we commissioned XD Consulting to carry out the report, and they identified all the various resources that we can use. So we're looking at the biomass resources coming from forestry residues, but also looking at what feeds into the district heating, those waste heats or excess heat coming out of industry, coming out of data centers that can feed into district heating systems, as well as obviously looking at the heat pump scenario as well. So it looks at all the resources that are available there. And what's quite interesting is we have enough resources to oversupply the heat in Ireland. You know, we've ample resources to replace all fossil fuels. It's just a matter of how we mobilize that. So, you know, within the focus for just in terms of the district heating side of that, there is, as Alexandra pointed out, there's a target there of getting 10% national heating by 2030 through district heating. That's predominantly by focusing on high heat density areas. So obviously urban centres, they're looking at Dublin, Cork, Limerick and Drogheda is what they've picked out within it. And you can, if anyone wants to look at the Irish Heat Atlas, which is produced by the Irish District Heating Association, that's available online as well. And it'll give you, it's a map basically of Ireland, gives you a rough idea of what areas are high density heat. So within that, there's also identified quite a number of those resources that are available. The waste heats are working out around 4 terawatt hours, a little over 4.5 terawatt hours. Let's put into context, the entire heat market in Ireland is 56. So little under 10% could be provided purely from waste heat, you know, coming from industry. So that's a resource we really should be tapping in on. But then it also outlines a number of the issues, how we, you know, the barriers to that development. Definitely the resources are there. Definitely the technology is there to do this through district heating. So the next thing is what are the barriers, and they're all desktop barriers. So things like the building regulations don't recognize district heating as well as it should. So that needs to be looked at. There is a need for greater access to incentives to allow district heating to be put in place. And then within Ireland itself, we're not like other European countries. We've done a tour over to Denmark about 5 years ago, looking at district heating systems over there. There's 400 district heating systems around the country. They're well used to operating them, and also in how they're built in terms of ownership, that sort of thing. So what we need to look at here in Ireland is things like, how do you organise ownership? It should be owned by the local authority, should be owned by Irish Water, should be a local community group. You know, how are you going to set that? If it's a community system, where is the ownership and who's responsible for what parts? You have to look at, if you're putting it through a town, one of the biggest customers, single customers, is going to be state agencies, but there's no central procurement for heat. So you're having to go and procure heat individually or to procure through procurement procedures for, you know, whether it's hospitals or schools or office buildings belong to government agencies. All of those will have to be gone to separately and go through separate procedures to take them on as customers. So we need to look at how we can streamline that for district heating. And also we need to look at, again, as pointed out earlier, any sort of grant aid. So you can get an SSRH, a support scheme for renewable heat. If you put in a biomass plant and you're going to provide heat into the district heating, you can get grant aid for the person that produces the heat. But maybe we need to be looking at other downstream support, such as, say, connection grant. So if householders are looking to connect to the district heating, or businesses are looking to connect, that they're assisted in that capital cost.
Okay, thanks very much, Noel, for your update on the renewable heat plan. And just to let attendees know that there will be a webinar next week on the renewable heat plan, and we would encourage you to log into that to find out more about the plan and what it contains. The main objective of the plan is to try and encourage the government through the revision of the Climate Action Plan to set a 40% target for renewable heat. Over to you, Rory. Noel has talked about some of the various challenges associated with district heating systems in Ireland. Can you maybe give us an outline of systems that you have installed in Northern Ireland and indeed in the Republic of Ireland, or projects you have been involved in? If you could just unmute, Rory, sorry.
Okay.
Yes.
Yeah, I'm just reflecting the market here. I'm with Rayhow nearly 20 years, and I suppose the initial sales of pre-insulated pipe went into your small domestic, your garage to your house, you know, and built from there. We got involved with the Tralee district heating scheme back in 2008. That was a real sort of eye-opener, you know, biomass, centralized biomass boiler, apartments. I think there was a swimming pool or library attached, etc. It's a pity that we haven't more of those Tralee projects around the country. You know, I'm sure there's plenty of opportunities, but is that an educational thing, or is that shared information of how these schemes work? I don't know the benefits. You know, did it run smoothly in the end? Is that information widely available to share with interested communities? Back in 2012, then I think the introduction of the RHI, especially in the Northern Ireland context for myself, opened up massive opportunities with the space, specifically with the agricultural sector, biomass boilers into poultry units, etc., AD plants across the north. When I'm actually looking at the bioenergy map here, and it's very obvious, you know, the scale of AD in Northern Ireland as opposed to the south. Massive opportunities in that respect with those businesses, and we've seen repeat business over the years where people are upscaling or adding new buildings, or, you know, to the network once it's installed. The only thing I'd say is that, you know, when people are looking at these projects, that they shouldn't think small, they should think big, you know, about future expansion and where things could go. We've done everything. We've done everything from hotels, you know, holiday cottages, hospital connections with remote biomass boilers, swimming pools, you name it. We've sort of been involved in it over the years. Again, we're probably, as a pipe man, we're impartial. We're not really worried about how the heat's produced or where it's delivered, but we'll assist in
getting it there,
getting that to its destination, you know,
okay,
correctly sized.
Thanks, Rory, for that insight. So if we go to a couple of the questions which have come in, I maybe go to you, Alexandra, to them, and if anyone else wants to join in or assist in the answering, feel free.
Yeah, sure.
So John, first of all, thanks, John, for joining. Are there technical reasons for preventing leak detection wires being incorporated into plastic district heating piping systems?
Generally, district heating pipework in steel was the one to have leak detection, and that was driven by the fact that corrosion appears and is a risk on a regular basis, as I mentioned, because you have the welding on a 6 to 12 meter lengths on a regular basis. So generally, leak detection is a bit of a legacy from the steel systems. But if we talk about technical reasons why leak detection should not be installed in plastic, there have been trials to do that just to match the requirements of the market. But it happened that there have been quite a lot of false alarms for polymer systems, and they were due to the fact that the polymer pipe itself has a level of it's a bit porous, and there would be a small amount of steam, a very small amount, but still possible to go through the pipework and affect the leak detection system and create that false alarm, so where there will be no leak. So those kind of systems have not been really introduced, and leak detection is not a thing really for polymer systems. But there are other ways of detecting leaks should there have been an accident on site or somebody just drilled through the pipe, and that can be assessed with a few either invasive or non-invasive methods. So there will be either thermal imaging or ultrasonic systems. You have even drones flying over the route of the district heating system, trying to figure out where the leak is. And of course, there is tracer gas or things like that, where you need to empty the system and then put the gas through to identify where exactly the leak is. So there are methods if it is needed.
Okay, thank you. Question from Donald. Thanks, Donald, for joining again this morning. The CIBSE this month had a 1 megawatt installation in the UK based on heat pumps and storage for 500,000 euros. Could biomass be competitive? Is Donald's question.
Is that sterling or euros?
Sterling.
Okay.
So I don't know, Rory or Alexandra, do you want to maybe comment on that, or is it something you would?
Not something I could answer, I'm afraid, Sean.
Okay, Alexandra,
I guess
do you want to come in on it?
it's hard for us to assess the cost of the whole system in this case, because every system is really unique. And it's not only unique by its setup, the types of buildings connected, the distances between buildings. It's also unique to how exactly that biomass is sourced. So you can have waste biomass that you're utilizing as part of your fuel source, and in the long run, that will be more efficient and cost efficient than buying through pellets for your system. So can be.
And are heat pumps and storage something which is being used extensively in the UK, or is biomass being more popular or more used more widely?
I think biomass has been used widely, but we're moving towards heat pumps a lot more at the moment, and dropping the temperature of the systems to say 60, 55 degrees.
Okay, Dawn, we'll have to maybe look at your question and maybe have a chat with you about that again. But thanks anyways for your question.
Just on that, I suppose there is your costs on biomass have come in around 3.5 cents at 4 cents a kilowatt hour. If you're using heat pumps based on daytime electricity, it's 20 cents divided by your COP, which would be about a third of that. And if you're nighttime electricity, it's say 10 cents. So it really comes out to the system itself, whether you're including enough storage. You will need daytime electricity going into that system as well. So your cost per unit of energy will be higher, considerably higher. So it comes down to the meat of the project itself, and each one will have to be assessed. Each technology will have has a place in this, but it just really depends on what's available. It depends on the green credentials of that as well. As we put more and more electrification of heat and electrification of transport, it's going to be harder to supply all of that with renewable electricity all of the time. So we just have to take account of the carbon footprint of all.
Okay, thanks, Noel. Question from Brian: what is the plumbing configuration inside the house? Simple heating exchange, any flow, DT meter? So Alexandra, I'd ask you to comment on that maybe.
Yeah. Mainly, it's a heat exchanger, which is at the house. Sometimes, if it's a council-owned building, they are installed on the outside of the house in a box. And if it's privately owned, it's indoors where the pipework is connected from the district heating distribution. And then after the heat exchanger, you have your own loop of pipework in the building, which is a very different circuit. Yes, you would have a meter inside as well. And that meter will measure only the heat that you have received. So all the heat losses will be on the operator. Okay,
thanks for your answer, Alexandra. If I could come to you, Rory, just there's one question about the RHI in the north. Did it actually lead to any significant district heating implementation, and maybe just if you could comment on the SSRH program in the Republic of Ireland. And we know that the SSRH is rolling out. There's a number of projects now on the payment cycle. We've worked closely with the SEI to address issues associated with this implementation, but I know that district heating is an option from the SSRH perspective. So Rory, would you like to comment on that in terms of the RHI in the north and actually also the SSRH in the south?
Well, I suppose from the point of view of unfortunately the scandal, the cash for ash scandal, put the brakes on a lot of things, and said it has delayed the SSRH complete rollout for a number of years now. But I suppose due diligence and government, it's policy really that we get everything right before we progress on these projects.
And just on with regard to the north, then was there a lot of district heating systems? You mentioned poultry farmers, so they might have 4 or 5.
I'd call them small network systems. Mostly on your AD side, you had a lot of expansion. You had individuals selling heat to adjacent landowners, building specific buildings to basically use that heat because they underestimated what they could actually get from these houses, etc. So it was I'm still going back to projects that we put in 5 and 6 years ago and extending those networks.
Okay. So it was more localized and it was more smaller systems.
But again, you have, I spoke to somebody in County Meath 10 years ago, and he was already looking ahead at, supplying heat a mile down the road, but the policies weren't in place at the time, for him to be able to achieve that, economically.
Okay.
So.
Okay. All right. Well, thanks for that, Rory. Go back to Alexandra there for a question there on the UK. You mentioned in your presentation about the ban on gas boilers, and the question here is that only for new builds, or is there any plans for retrofitting old buildings in the UK?
At the moment,
sorry, go on.
At the moment, it's new build only. So we're starting from building new networks in a different way for new developments, but I'm sure that the retrofit will be in place as well. But nobody will take out the boiler out of your house yet. But soon, I'm sure that this will be part of the policy too.
And I know here there's a significant focus on retrofitting of older buildings to improve their energy efficiency. Is that something that the UK government is also embarking upon?
Yes, they are, and that's the first point really, because however efficient your energy source is, if you're losing the heat constantly through the envelope of the building, that's not helping anyone really. So there have been a few different schemes in UK to insulate the houses and incentivize this to homeowners as well.
Okay. Just before we conclude, I'd just like to let all our attendees know that I posted a link to the 40 by 30 report into the chat, so you should have received that, and we'd be happy to receive your feedback on that report. As Noel said, RBO was one of the sponsors of this report. It was developed through Renewable Energy Ireland, where the Irish Bioenergy Association acted in administrative capacity for the development of the 40 by 30 report. So if there's anyone that has any questions, feedback, or any information they'd like to provide on the report, we'd be happy to accept that, and feel free to send it on to us by email, or indeed get in touch with us by our social media channels. I think that concludes the questions for this morning. I'd like to thank very much Rory and Alexandra for joining us this morning and presenting and we wish REHAU, as a valued member of the Irish Bioenergy Association, best of luck in your rollout of district heating systems across Ireland and indeed across the UK. And hopefully we can have you back at a future date to further discuss this important topic.
Thank you.
I'd like to also acknowledge Noel Gavigan and thank Noel for his contribution this morning. And I'd like to also thank and acknowledge the contribution of, or thank Teresa O'Brien, who's works behind the scenes to get all of this set up for us and to make sure the webinars run smoothly. So thanks very much, Teresa, for your ongoing work in rolling out this series. And finally, I'd just like to thank all our participants this morning. Thank you all for joining us, and we do hope that we can welcome you back to our next webinar in 2 weeks' time, where we will have another topic for you on the whole area of community and energy, which is certainly proving popular with lots of community groups across the country in terms of how they can get involved in the renewable energy sector. So with that, we will conclude just to say thanks again to everyone, and we look forward to welcome you back again on the next occasion. See you all now. Bye-bye.